Hello, Matt Davis here with more quiz help. This one is from a review quiz for Chapter 8. Suppose that we will be computing a 98% confidence interval for a population mean and that we estimate the minimum for this population to be about 350 and the maximum to be about 777. Calculate the minimum sample size required if we want our confidence interval to have a margin of error of at most 15. Enter a whole number. So the first thing we're going to do is make some changes for the purpose of giving help rather than answers. So instead of the 98% confidence, we're going to go with 95% confidence on this one. Instead of a sample size of 777, we're going to go with 889. And instead of a margin of error of at most 15, we're going to change that to a 17. All right, so let's start trying to figure out what it is we're trying to find. They want us to calculate a sample size, and then this is for a situation where we're doing an interval for a population mean. So we're trying to find a sample size in the setting of a mean. So if we go look at our formula sheet for Chapter 8 on confidence intervals, the top row right here is the one for means, and then the piece of that we're going to use is sample size, so either this one or this one. The key here being that they gave us a max and a minimum value, and we're going to use that max and minimum value to guess at sigma. We're going to make a guess at sigma or a sigma g. So that's the formula we're going to use. So let's go ahead and head back and make use of that formula. All right, so we just decided we're going to work with n equals z star times sigma g divided by E all squared. So we just need to assemble all the pieces for that. So let's go ahead and do that. So first of all, the sigma g, that was the question from the previous problem. And so the way you do that is you take the maximum and the minimum that they gave you, which was 889 minus 350, and you divide that by 4. And that's fairly straightforward on the calculator, so I'll just show you the answer, but make sure you do remember to put parentheses around the numerator because of the subtraction. When you do that, you get 134.75. So that's going to be our sigma g. And then we need E. E was given to us to be 17. That's this number right there. And then we still need the z star. So the z star is going to be for the 95% confidence that we're using. So we'll start off drawing a bell-shaped curve. We'll put 95% in the middle as 0.95. If you subtract that from 1, you get 0.05 left over. Cut that in half, put half on each side, you get 0.025. Always remember to add these three numbers together to make sure you get a total of 1. That makes sure you remembered to split up the leftover area. Make sure that you didn't have any decimal place mistakes. And then this value right here will be our z star. It will also be z sub 0.025 because it's a z-score with area 0.025 to its right. So if we go back to the formula sheet, scroll to the second page, we can look at the t of 0.025 column. And all of these are t-scores with a 0.025 in the tail, but we just keep going down that column. Again, all t-scores. We get to this break, that one down there at the bottom, that one right there is our z-score. Z-scores are in the separated row. All right, so 1.960 for our z-star. So z-star is approximately 1.960, and now we have all the pieces we need. So this is kind of our scratch work to get all the pieces assembled. Now we can get going on the formula. That z-star we just found of 1.960 times our guess at sigma, which worked out to be 134.75. Divide that by the desired margin of error, which is 17, and then square all of that. Forgetting to square is a fairly common mistake, so definitely remember to write the square and to do the square on the calculator. So let's head over to the calculator and see what we get for this. All right, so open parentheses, put all three numbers in, 1.960 times 134.75. Don't close the parentheses yet. I've got a little typo here. So 134.75 divided by 17. Once you get all three of the numbers in there, then you can close the parenthesis and then square. That makes sure that you're squaring all three of those numbers, the whole fraction, not just the denominator or the numerator. All right, so we press enter, we get 241.36. Let's carry that over. So approximately 241.36. When you do a sample size, you always want to round up. So we're going to use n equals 242. Even though 3/6 would normally indicate a round down because the 3 is smaller than 5, with sample size you always round up. So 242 is what we'd end up entering in to active learning. All right, so looking at a few spots where this has the potential to go wrong, choosing the formula correctly right at the beginning is a big deal. We don't have S, so we're not going to use the formula with S in it. This is a problem about a mean, not a proportion. And we have a max and a min, so we're going to be making a guess at sigma. Remembering to put the square on the formula is a big deal, and remembering to do that in the calculator with parentheses is a big deal. Other things is calculating the sigma g. Make sure you put parentheses around the top, otherwise that can come out wrong. If you forget the parentheses, that'll mess it up. It'll come out wrong. Make sure that you add the three areas together so that you end up looking at the correct value of z star. And it is a z, not a t, because we're working with the sigma g formula. And then finally, despite this being a 0.36, we did round up. That can be tricky too. All right, hopefully somewhere in there you saw the spot that was giving you trouble. Good luck as you head back to the quiz.